This is a video on the user command find and regular expressions in Dyalog APL. Very often you want to know where some text resides in some files on your disk. Maybe because you're looking for code in script files. I know I do it every once in a while. Under Linux or Unix, there are commands offered natively by the operating system, for example grep or find. But under Windows it's a bit trickier. There are a number of third-party programs available, like Total Commander, but nothing is always available from APL. The procedure is fairly simple. Once you find all the files matching a specific extension, for example, all the txt files under a known folder in its subfolders, this would become, for example, this expression where the name of your program is find all files. The folder you want to look into is \tmp, and the extensions you want to look for would be .txt and .dialog, for example. Then for each one of the files here in all files, you would find where in that file your text is found, preferably with a nice little report showing the line number as well as the matches. Now, find all files can take many forms, but typically you'll make calls to the operating system to retrieve all the files matching the extension given in the folder wanted and its subfolder. For example, we could have a bunch of files in this folder here, and these are the ones that we actually want to search into, and the subfolders also. Report will read in the text of the file and, for example, use epsilon on the bar, the APL function find, to find the matches and display a nice little report. Let's have a look at finding the files. It involves a few steps and possibly a recursive call. We can try something like this to list all the files in the folder. This is Dyalog APL, but it would be similar in other APLs. Here we have the list of all the files in folder tmp/find. Now we can put that into a variable, and here is where the txt files are. There's 3 of them. We need to extract the file names themselves. This can be rewritten like this. And now for the folders. We need to ignore those dot and dot names there. There are many ways to do this. This is but one manner. We can put this all together into a single program. We can see here that on line 1 we ask for the list of files using the dir command. On line 2 we find which ones match the files that have the extension we want. And on line 3 we extract the names by appending the folder in front of them. On line 5 we find which ones are folders, and on line 6 to 8 we go through each one of them, recursively call our function on the subfolders that we found. Now let's try it. This will find only one type of extension. To find more than one, we'd need to modify the program or call the program once per extension. Obviously, this will vary from one APL to another, and even from one version of the same APL to another. It will also vary depending on the operating system. Under Unix, for example, we would have to use the ls program and parse the result differently. Dyalog came up with a new system function to bypass the operating system problem, quad-n-info. Quad-n-info is a Dyalog version 15 system function that accepts a file path or a tie number and returns properties, information about it. Up to 8 pieces of information, depending on the left argument. For example, to know the path and the type properties of a file, you would use this expression here. Let's turn on boxing, you'll see better. 0 on the left is for the name, the path that we want. 1 is for the type. So here we ask for 0 and 1, we get 2 results. By default, the right argument must be the name of an existing file or a tie number. The name returned is a string. The type is an integer in the range 0 to 7. 1 means it's a folder, 2 means it's a regular file, 4 is a link, and so on. Quadinfo also accepts a variant, wildcard, which allows us to use patterns in the file name. It then returns a list of property values, 1 per property requested. For example, to retrieve all the file name and type of the files in the folder \tmp \find that end with an A and have a three-letter extension, you would use this expression here. Here, the star is a substitute for zero or more characters in a file name or extension. A question mark is a substitute for any single character. It's like the DOS Windows wildcard characters. It's the same meaning. Here we want to retrieve the name and type of all the files in a given folder in order to find out which ones are folders so we can recurse. So we would specify, or because wildcard is the principal property, we can drop the string wildcard. We can't specify an extension here because we want to recurse. We want to know which names are folders. And we want to find the type of all files, just like the quad cmd dir above. So doing this will tell us which names are folders, and we can recurse gathering the names until there are no more subfolders. To find the names with a specific extension, we could do something like this, which will tell us which names are folders. We found 3 names. But this won't work if we have more than one extension, just like above. Obviously, we can loop for each extension, but we can also make use of the new quad and parts system function in Dyalog 15, which splits a file path into its 3 constituent sections: the folder path, the base name, and the extension. Applying this function to all our file names and keeping only the extension as this expression here would not only do the trick, but be far easier to do. Our program above becomes simplified and not to mention faster. So we have the same thing here, except that now instead of calling quad cmd, we use quad ninfo, which is faster. And then we extract the files. We find the files that have an extension as specified in the right argument. There could be several. And then we loop, calling ourselves on each one of the subfolders. We need to pass it a list because we can have one or we can have several, but if we only have one, we have to enclose it. And we get the same result. Reading each file is a bit trickier than it seems. Most files containing APL code will not be ASCII. They may be ANSI, but they won't be ASCII. If you are using an APL which is not Unicode, you will have to perform some form of translation before making comparisons. So let's read a file like this. Most APL will have a quadNtie and a quadnrange system function to open a file and read it. This doesn't look bad except for those 3 funny looking characters at the beginning. Let's try with some APL code. What's the text? Whoa, something's amiss. This text is definitely not ANSI. We got all these funny looking symbols there. It's Unicode. How do I know? The 3 funny little characters at the beginning. If we take them and we look at them, these are a bomb, a byte order mark. It tells us that the text is encoded in UTF-8 format. We can decode it this way. The first quad UCS is to turn the characters into numbers. The second one is to turn those numbers into characters again with, using the left argument, UTF-8 format. Oh, that's better. We can write a program to read a file, find the encoding, and decode the stream properly. We would have to account for the various encodings, which might take a bit of coding, time, and testing. Or, if we are using Dyalog, we can use the new quad and get system function, which also appeared in V15. Quad and get returns 3 things: the text, the encoding used, if any, and the line endings in the file. Here, it says that it's UTF-8 encoded with a byte order mark at the beginning of the file. The line endings were carriage return line feed. This is a Windows system. And it returns the text normalized with new line characters after each line. Here we're only picking the first 45 characters just to show you. That's a real time saver. With that in hand, we can concentrate on finding our string in the text. For example, if we are looking for the string :case in our text, we can use this expression. But that only tells us where it begins. We don't know the context. An average programmer should be able to assemble the pieces in a few hours right now. When this is done, a simple bracket copy of the utility in your workspace will allow you to search your disk the way you want. In Dyalog, somebody has been through this trouble already. The user command find in group file will do that for you. There is even a replace command to perform replacements on the spot, but we won't see it here. These commands were written for Salt, a simple API library toolkit which deals with script files under the .dialog extension. But it can also be used to search non-salted files too. They work in conjunction with the bracket setting workdir, which specifies which folders you are working with at the moment. So for example, now our working directories are \px/main, \utils, and \GUI. Let's change it to work with the salt folders themselves. We will be searching them. This is for the sake of the example. And let's try to find the string omega equals 1. So we found 5 places in 4 files. This command nicely displays the file where the matches were found. The lines with their line number and a line with carets showing where the match or matches were found. It even included a total at the end. But it only searched .dialog files in the salt folders. What if we wanted to search other types of files in other folders? There is a way. Both commands, find and replace, accept the modifiers to change the folders and specify the type or extension to use. We can even search in multiple file types. So here we found one, and this time we look for txt and doc extensions. And we found 2. What about regular expressions? You may be interested in more than a simple text string search. Since version 12.1, Dyalog supports full regular expressions with the PCRE engine via the system operators quad S and quad R. To tell find you want to use regular expressions, you use the switch regex. For example, to find when 8 letter names beginning with an A are assigned a value, you could use, note that we're still searching script files in the salt folder here, this expression. This requires that you know a bit about regular expressions. Here, let me go back up. This argument is a regular expression that reads like this. \b means find the edge, find a beginning or an end of a word. The A is taken literally, it means just look for an A. The \w means look for a word forming character, which in a regular expression is a Latin letter, A to Z, or an underbar, or a number. And the 7 within braces means make the preceding character exactly 7 times. So that \w must be repeated exactly 7 times. And then the arrow means look for an assignment arrow. So we're effectively looking for a word starting with an A, followed by 7 letters, followed by an assignment arrow, an 8-letter variable starting with an A. Regular expressions are a complex subject, but it is worth spending a bit of time on them. They come back regularly, no pun intended, and can save you a lot of work and or time. They work with Unicode characters as well, so no extra work is needed on your part. You have to pay attention when dealing with APL code though. The above example would not detect names that include, for example, a delta and would report false positives on quad names, for example, quad WSID. To detect an APL name, you would have to use this expression here. Yeah, I know what you think. This says, case insensitive mode. Names can be in upper or lower case characters. This says, look for either alpha alpha, alpha, omega omega, or omega, which are all valid Dyalog APL names. The order is important, otherwise alpha alpha would never be found if it was after alpha. Or look for a name that is not preceded by space colon. This is to eliminate the colon keywords in the language. That is not preceded by a colon at the beginning of a line. Again, this is the colon keyword thing, which could happen at the beginning of a line. which is not preceded by a quad or a name forming character because we don't want to start in the middle of a name, which consists of a letter, an underbar, a delta or delta underbar, and possibly followed by zero or more letters, underbar, delta, delta underbar, or numbers. This is quite a mouthful, and that is ignoring all the accented characters. Let's try it. It's good, but see how it found false positives in text and comments. We can fix that too with, guess what? Another regular expression. But that can be tricky. There's a way to do that, but a warning should be issued before. This is not for the faint-hearted. You may want to be seated properly before watching any further. First, let me show you where the string text is found. We can see that the string appears in comments here and in text there. Here is an expression to find the characters text not within comments or strings in the current working directory. And here's why it works. The parent means capture the following. Quote means look for a quote. This means look for zero or more non-quote characters. Any character that is not a quote, follow it. And then it must be followed by a quote. That describes a string. If it doesn't find that, then look for a lamp symbol followed by any string until the end of the line. This is a comment. The first one was an expression to find a string. This is an expression to find a comment. And this entire thing here means find either a string or a comment. And the question mark means if you don't find it, it's okay. Find it 0 or 1 time. This expression means, did we capture anything in the last group of parentheses? If we did, then this means skip here whenever there's a failure next after this. In other words, move the pointer in the string where we're searching past either the string that we found or the comment, but only if we have a failure. And then we provoke a failure, so the engine will move to the skipped position, which is after the string or after the comment. We could also have used star F instead of star fail. If we did not find a string or a comment at the position in the line, then we look for our expression text. And now for the scary part. Imagine that you want to know where variables are assigned a number in your script file. You could use a regex like this one here. But you would be missing some variables containing deltas or underbar, and you could be finding false positives like quad WA. You could also find your text in strings or comments, but that is less likely to happen with an assignment. But in case you want to avoid it, you could combine both regular expressions above like this. How about that? So you can see here that R is assigned a number and delta underbar 1 is assigned the number 33. It worked. Now I'll let you go. Hope you didn't fall off your chair. Note that the comment was excluded from the match. It goes to show that regular expressions are to be reckoned with. They are quite powerful. I hope you enjoy this. See you next time.